All right, good morning, everyone. Welcome to this session. Let's see, let me try to figure this out. So I'm going to talk about Windows Server storage for non-Windows clients. Hopefully that's the session you're here for. My name is Mallikarjun. I'm a PM in the Windows Server group, in the file server group within that. So let me set a little bit of discussion context, and then we can dive into details. So it may come across as a surprise, but probably most of you guys know this on the other hand as well. Windows Server storage solutions are used widely in heterogeneous environments, heterogeneous data centers. So Microsoft makes a significant investment to make sure that these technologies that serve non-Windows clients actually work great, and they perform at scale, and they offer high performance. And I'm going to focus on two specific technologies that we work on within my group to enable the non-Windows clients scenarios work great. The two features are NFS and iSCSI. These are really cool technologies, so and there's a lot of little details, features, and cool things about these technologies that I'm going to breeze through more or less, because each one of this, honestly, is a full session in itself. I'm going to try to package them down into one session here. So if you want more details on any of these, just grab me after this session, and I hear that there's really nothing else scheduled in this room for about an hour or so after our session finishes. So I will hang around here as long as you want me to talk to them about, right? Just one tidbit of information, by the way. The gentleman who actually wrote, or co-wrote, I should say, the NFS 4.1 protocol specification, works for Microsoft. He's one of my colleagues, Spencer Shepler. And I'm a co-author of the original iSCSI protocol specification. And I continue to own and edit the iSCSI protocol specification, IETF, in Storage Maintenance Working Group. And another one of my colleagues, Tom Talpe, is the co-chair of the Storm Working Group in IETF. So Microsoft is contributing to the NFS and iSCSI technologies in different ways. And the other thing is these technologies ship in Windows Server SKUs, but they also are part of the Windows Storage Server SKUs that several OEM partners such as HP and Dell ship. So basically, these are the technologies that drive the storage appliances shipped by partners as well. So just a little bit of context on where iSCSI and SMB and NFS, DFSR, all these things fit together. This is a little bit of a sort of a context slide, so to speak. There's roughly, like, if you think of it as 4 buckets: Windows Server workloads, non-Windows Server workloads, and then again within that, the Windows Information Worker, non-Windows Information Worker. So basically, the stuff that we're going to talk about today fits in these two categories, right? Windows Server workloads, host boot from iSCSI target. I have some detail coming up on that. And then non-Windows Server workloads, obviously, iSCSI plays a role there as well, right? And non-Windows Information Worker, NFS for Windows clients as an example, or VMware, right? So let's go ahead with that. Let's jump into NFS first and spend some time on that. Sridhar is one of my colleague PMs who could not be here. He's actually the owning PM in my group for NFS. So I'm going to speak on behalf of him. In terms of the topics, these are the rough overall topics I'm going to talk about. I may spend a little bit more time on some of them, sort of breeze through some others. Again, feel free to grab me after the session if you want more details. And of course, I'll try to leave some time at the end for Q&A as well. NFS is a file sharing protocol, just like SMB, right? And way back, it's created as an IETF RFC, and work is continuing on in IETF on NFS 4.2, I believe, right now. And Microsoft shipped NFS versions of NFS server for a long time, and I have a sort of a detailed slide coming up on that. And this is really the solution for heterogeneous environments for sharing data across platforms. This is NFS history. This is really more for your reference. This is just to say that the protocol has been evolving for a long time. And NFS in Windows Server also has a long history. Microsoft Windows Server has been supporting NFS since 2003-ish days. And 2012 and 2012 R2 is the very last item there. Again, we added a bunch of cool things in Windows Server 2012, continuous availability, a bunch of manageability enhancements like WMI v2 provider, PowerShell commandlets, etc. I have much more detail coming up on that. So from an overall deployment scenarios, when do you use NFS? By the way, how many folks here use NFS Server here? Do anyone use NFS? Okay, a significant chunk. Yeah, thank you. So file sharing in heterogeneous environments, right? Windows clients, Unix clients want to get to the same data. How do you enable them, right? You put one Windows file server that can actually serve out both SMB and NFS off of the same file server head, same NAS head, and both clients can get to the same data. And also, if you have a clients, even though you may not have data sharing or cross-platform sharing at the same time, you may have some clients, some set of clients that want to get to their data, some non-Windows clients, sorry, I should have said, that want to get to their data like VMware, VMs. They're the only ones getting to the data, but again, let's say that's more or less mostly a Windows shop, and they want to keep Windows for the back end. And then migrating between platforms. That's the other occasion where you might want to have access to the data from Windows and non-Windows in some fashion. And continuous availability. I'm trying to get to my machine here, and hopefully I'll be able to show a demo of it in action. Okay, I'll keep trying as we speak. But basically, this is the cool feature where even if one of your Windows file servers serving out NFS, acting as the NFS server, crashes, the VMware clients, the VMs or Linux clients, they don't even know about the fact. Magically, the failover happens, not a single I/O fails. That's what we mean by continuous availability, right? So I'll talk more about that. So they are the typical scenarios. Let's just go into what's in 2012 R2, right? We made a bunch of enhancements, like I said, the big one being adding v4.1 server support. Right? That's the new one that we added back in 2012, and that's also in 2012 R2. And I have more slides coming up on each of these areas. And by the way, all these capabilities first all shipped in 2012, and we have made minor improvements here and there, but for the most part, these are unchanged from 2012. Let's see. So before we go into why we even bothered to implement 4.1, this was a significant investment. That a large team worked on it to make it highly performant. There are a bunch of differences between NFS v3 and NFS v4.1, right? As the table states here, right, we don't necessarily have to walk through every one of those rows, but the big difference being stateful, right? NFS v4.1 has a lot of state, leases, directory delegations, etc., right? That stuff is all, that's the big difference. And there's a bunch of changes in ACLs, and PNFS is another new thing that got added in v4.1, right? And compounding of RPCs to improve performance, that was also done in 4.1. And so this is sort of the context for us going into implementation of NFS 4.1 on Windows Server. So what did we actually implement in the NFS 4.1 RFC, right? RFC 5661, basically we took it and all mandatory aspects of it, attributes, methods, everything in there is implemented. And the top level features that we implemented are these: pseudo file system, volume mount point support, compounding of RPC sessions. Basically, that is the stateful nature of the protocol that I was talking about. Trunking and port multiplexing, right? Basically, instead of having a bunch of ports, one for network status monitoring, lock management, NFS, mount, instead of managing all these firewall ports, you have one port that can multiplex all the incoming traffic, right? So that's basically what we have implemented out of that. And let's talk a little bit about pseudo file system. Let me try getting back to my server again. Basically the idea here is that the shares that are exposed by the NFS file server in this case, they have the same common prefix as you can see there, like tom backup, tom docs, tom dev. So these inherently implicitly form, they're all part of one pseudo namespace, right? So from a client's perspective, I can actually go ahead and mount the pseudo namespace tom, and all the file shares within that namespace get mounted, right? So I'll talk to more of this during the demo. All right. So what did we not implement, right? This is the sort of the other side of the coin. We did not implement a few features, probably a couple of interesting ones for PNFS, and that's primarily because we have not seen a lot of industry adoption, and we're still watching the industry adoption to see whether it's going to take off or not. We actually have not seen any clients that do this, so we did not implement that. And in terms of Windows file systems, we support NTFS, which is the most popular file system format. So that's basically about the NFS 4.1 protocol support, right? So let's just talk a little bit about the infrastructure improvements that don't show through as obvious big features, but actually improve the reliability, performance, and stability of the NFS server feature. RPC XDR, we basically switched from one TDI interface, one interface to WinSock infrastructure interface under the covers. So that gives us better scalability. Again, this is not one of the things that obviously shows through, but it's a big improvement under the covers. RPC port multiplexer, we kind of talked about that. And auto-tuning of caches and thread pools. This basically means that the NFS administrator doesn't have to worry about them as much. It automatically tries to keep up with the workload and automatically tries to bump up or bump down the resources. And dynamic endpoints for per interface registration. I have more detail coming up on this in the continuous availability side of the slide. Basically, it means that faster failovers can happen. We don't need to fail over a whole bunch of resources that are not otherwise used. So you can selectively only fail over the resources that really matter to your NFS traffic. Kerberos privacy implementation, the Kerberos integrity and privacy and core Kerberos, all of them are implemented. That basically gives you more secure deployments with secure authentication. Then we made a set of changes around availability. This is what I was talking about earlier as continuous availability, right? So what's happening here really is that there's a file server cluster here, 2-node file server cluster that's exposing a bunch of NFS shares that's accessed by this client, shown down there at the bottom. And when the first red node, let's call it the red node, fails in the 2-node file server cluster, all the file server shares get failed over to the second node, and the client experiences what we call as a brief brownout. Brownout meaning it basically sees one IO slowing down a little bit or a few IOs slowing down a little bit while the failover is in progress. But once the failover completes, the IOs continue on. There are no IO failures. The fact that the failover had happened was beyond client's knowledge. So a bunch of things went into making this actually happen. And the first big thing is improving the clustering resource model, right? So we actually have one resource per network name now, instead of one for each share. Again, this goes to the same point I was making earlier, that of keeping the number of resources that are failing over to the minimum, right? You don't want to fail over a bunch of resources and expect them to cascade through their state without needing it. So one resource per network name, meaning whatever client access point you have on the clustering for that specific NFS server, that's really the only one that has a resource now. And a bunch of tuning has gone into that as well. And the no more wildcard interface registration, this contributes to the same point. The network status monitor notifications are sent after failover. This is really the sort of the secret sauce, so to speak, that actually contributes to the notion of continuous availability, because the clients are not waiting for the TCP timeouts to happen. They're not waiting for the NFS IOs to fail, right? They're just being told up front, hey, you got a broken NFS IO, like NFS connection, just go here, right? So that's basically what's contributing to the continuous availability there. This kind of shows this a little bit visually. There's I/O going on from two clients there, basically two file clients, both going to one node in a Windows Server failover cluster. And that guy goes down, and basically the I/O is halted for a few seconds, unbeknownst to the application, and the specific access point fails over to the other node, and the I/O resumes, right? Again, that's the apps wouldn't know about that, right? So it's just describing one typical deployment scenario that we had in mind while designing continuous availability. And the description to the far right box. That's not the only one that obviously this works in, but that's the thing we wanted to work best. That's the one we tuned it for, right? Again, if my machine works, I'll show this in not working. It's actually, I'm not able to get through to this one machine for some reason. So the transparent failover is a big deal. By the way, one question that I get frequently asked, hey, is it VMware certified, right? The answer to that is Microsoft directly does not certify against VMware compatibility. Their testing, but a bunch of OEM partners that we work with who actually OEM this technology into their appliances, such as HP Store Easy products, for example, they certify against VMware. So you have the assurance that this works with VMware. And actually, if you look at that, the best practices white paper from VMware, that actually recommends a failover like within 120 seconds, I believe. Yeah, 120 seconds, right? That's the ESX best practice recommendation. And we failover well within that, usually in less than 30 seconds, even with a very large workload running. So that's that. Okay, this comes to the difficult part here, I think. So what I'm going to do, I'm unfortunately not able to, for some reason, get through to my CentOS file client. So I'm going to just stick to the NFS server side of the house, and I'll just show you what I have. Hopefully that gives you a better appreciation for what there is. So I have a two-node cluster here, and I'm going to use the same cluster for both NFS and iSCSI parts of the talk, right? This is a two-node cluster. Demo 1 and Demo 2 are my two machines. And in terms of the highly available workloads running on that, I go to the roles, and I have a HA NFS FS, which is basically the cluster resource group for the highly available NFS server. And then a ITS, which is the iSCSI target server, the target server resource group again. We'll come back to that during the iSCSI part of the talk. But for NFS, as you can see here, let me try to zoom in. Okay. if I can get my mouse back. Okay, that's good. So these are the highly available shares that are exposed by this particular NFS server, right? I have two shares, Tom Backup, Tom Dev, that will together be one pseudo namespace, Tom namespace, right? That is mountable from a file client. Then I have one video file share here that is also exposed through NFS v3 actually. I would have shown v3 and v4.1 access concurrently to the same file server. But anyway, so they're all continuously available. That's the other cool thing that I want you guys to notice. They're all continuously available, meaning the failovers would not be basically noticeable by the file services clients, file clients, right? So that's that. Well, let me try one more time to get to the file client, my CentOS machine, which somehow is the only one that I cannot get to for today. All right, sorry. If that works, I'll come back. I would have shown continuous availability in action while CentOS is running. What I was going to do is basically I'll have the CentOS running and keep accessing a file and take down the specific node that currently hosts the NFS server and force a failover of the NFS server role that we just saw from node 1 to node 2. And while doing that, the CentOS client keeps running. It sees a little bit of a pause in the I/O. One I/O takes a little bit longer. I have system monitor running on my CentOS machine that actually tracks that and shows that it's about 5 or 6 seconds worth of pause. But other than that, as soon as the failover completes on the cluster node, the I/O continues on as if nothing had happened, right? That's what I would have shown, except I can't get to it. I apologize for that. So let's come back to this. And again, like I said, if I can get to that machine, I'll switch back to this as soon as I'm able to connect. So ID mapping improvements. What is ID mapping anyway, by the way? So when users access NFS files, the files via NFS, I should say, through their identities, right? They are using their user IDs, group IDs in Unix world, and they have no existence in the Windows file server, right? That's really the core of the ID mapping issue. So how do you map a user from a Unix world into the Windows world and actually authenticate that particular identity, right? That's really the crux of the problem. So there are actually a number of different ways of mapping IDs between the two worlds, as it turns out, and we support 4 of them. Let's bring up the first one. The first one that we recommend is just use Active Directory, lightweight directory services that acts as an identity mapping store on the NFS machine, on the NFS server. That's the nice thing about it is there's one commandlet for you to run that actually sets it all up for you. And then you have a set of commandlets to manage the identities into that mapping store. That actually helps you map the Unix identities into the Windows identities, right? And this is what I was just saying. There's a bunch of commandlets to create, query, edit, remove, and all that once you have the mapping store set up. And there's also other ways of mapping the identities. One is using just a flat file, Unix-like password group file. There's the pad down there, system root, system32 drivers, etc. You can just copy the flat file from the Unix world and make some adjustments and basically use your ID mapping solution, right? And there are others, like you can use full-blown Active Directory directory services, starting from Windows Server 2003 or 3-ish, I believe, 3 or 3R2. I think it's 3R2 actually. Active Directory ships with the necessary schema for this NFS mapping, identity mapping. So it's all there. You don't need to do anything. The existing AD should just work. And there's also the unmapped Unix user access, by the way. There's the U3A access, as we call it, meaning we just accept it. We don't know what it maps to, because if you don't have time to map, you just want to see whether or not it actually works, the access path works, just use U3A and you're good to go, right? So manageability improvements, I briefly talked about that. We have made a bunch of enhancements in 2012, and they continue on in 2012 R2 as well. WMI V2 provider, basically the old one is gone, and the new one, the SIM WMI V2 provider is in there. And that provides full backwards compatibility, and it works great. And we added a bunch of commandlets that actually makes the entire end-to-end scripting job much easier. And there's a little bit of an eye chart with all the different blocks, but that's just for your reference. So performance improvements. From 2008 R2 to 2012 R2, there's a significant improvement in NFS performance, both in terms of IOPS and the throughput, right, in the response time. So it kind of shows some of the graphs there. We see about roughly 30-35% improvement. And there's some additional pointers down there on how to tune the operating system overall. Right? Interoperability, that's really the core claim, right? That's why you guys are here, to see, hey, what does it actually work with, right? So this kind of lists all the things, all the different operating system clients that we tested with. And the one point to note here is NFS 4.1 client for Windows. It can be downloaded from University of Michigan's website. Microsoft closely collaborated with them to make it happen. We worked with them. We funded some of that. And the bottom line is it's available there. You can use it. And, of course, the NFS 4.1 client, again, from my CentOS machine, when it actually I can connect to, that also has a 4.1 client. Just as an example, you can connect from any 4.1 client, of course. And Microsoft participates in Connectathon events regularly. Pretty robust implementation. We participate regularly and make sure that it actually works with non-Windows clients. Here is an interesting snippet for you. Top 10 cool features of Windows Server 2012. It showed up as number 2, much to our pleasant surprise. So it's a great feature, and the performance is great. Here is a short URL for you to look up all about NFS on Windows Server. With that, I want to sort of transition into iSCSI side of the presentation. I don't know, how are we doing on time? Okay. So I think so again, like I said, there's a little bit of a breeze through. I know there was a lot of information in there, and again, iSCSI is going to be similar. I'll breeze through all the information there. Feel free to grab me, send me email after the session, whatever, just to follow up on any of these, right? Okay, iSCSI, a little bit of introduction. What is iSCSI? Well, the NFS protocol that we talked about until now is a file protocol. Now, iSCSI is a SCSI protocol, typically used for block storage, but it can be used pretty much for any storage. iSCSI is a transport protocol, just like Fiber Channel Protocol, right? FCP. And iSCSI can run on any network that TCP/IP runs on. iSCSI on Ethernet, and you name it, right? InfiniBand, any transport, basically. And the original protocol spec is 3720, and 5048 is the other spec that we worked on. I'm an editor for the latter and a co-author for the first. We clarified a bunch of things, and a lot of that stuff is also in the Microsoft implementation. This kind of gives a little bit of sort of context. I have one more slide coming up. Bear with me if you already know this, but basically I wanted to give a little bit of sort of jargon on all the terms that I would be using. So this is really the jargon. There's an application, and there's a SCSI client protocol. There's a SCSI client on the initiator side, and there's a storage server side. We have a SCSI server, and there's an iSCSI protocol layer running on the storage side as well. So initiator and target. Target is the one on the storage side. And the protocol that runs between the two is really the iSCSI protocol. And there's a SCSI protocol that runs above iSCSI protocol, right? So the SCSI and iSCSI both are there in an iSCSI solution. And they both run actually on top of TCP/IP. a little more jargon, right? I want to talk about two things. First of all, storage area network. This is one term that's commonly bandied around, like SAN. So what is SAN? Can be fiber channel SAN. That's the typical usage context for the term, but of course it can be IP SAN as well. And initiator and target, they communicate with each other using iSCSI and SCSI protocols on SAN, right? So how does the communication occur between target and initiator? Again, another rich trove for a lot of jargon here, right? First of all, the discovery of the target happens. It can be a static configuration of the initiator, or it can be an ISNS, like storage name services driven discovery. And once the target is identified, the initiator, obviously, as the name implies, takes the initiative and opens a TCP connection to the target. Then logs in. It goes through multiple phases of within the login. It goes through security negotiation, picking the specific authentication protocols that it should use, and then it goes into the operational negotiation, negotiating a bunch of parameters. What's the maximum burst size? What's the first burst length? How much data can I send you without soliciting, without you sending me a ready to transfer, right? So there's a bunch of things it actually goes through. Whether should I use digest or not, right? So there are all those things that it negotiates. And finally, when all the negotiation is done during the login phase, it enters what we call as the full feature phase. Full feature phase is really, once it is there, we call it an IT nexus. IT nexus, I and T stand for initiator and target. And once an IT nexus is established, the IOs can happen, right? Inquiry and report lengths are the first typical commands that come through on the wire, but they don't have to be. That's the I/O part of it. And finally, when it is all over, the IT nexus is typically ended by the initiator, but target can occasionally drop connections, or it is in trouble. It wants to escalate another recovery or something drastic, wants to take a drastic action, force the initiator to relog in. It may actually end the IT nexus on its own, right? The establishment of the IT nexus is always driven by the initiator, but the converse is not necessarily true. And finally, the TCP connection is turned down either gracefully or ungracefully, right? So just a little bit of history on iSCSI target versions in Windows Server. It went through a couple of versions, and the big thing for us back in 2012 was we pulled it in box, right? Until then, it was like a downloadable. You need to go to the website, download, all that good stuff. So in 2012, we pulled it in box, and we made it continuously available. That's the big deal there. And 2012, now in this version, 2012 R2, we added a bunch of new cool features that I'm going to talk more about. But before we jump there, though, let's just give me a little bit of usage scenarios context, and hey, why are we using it anyway? Exactly where is it used? So let me just give you how are customers using it, Windows customers using iSCSI target today, right? So let me just talk to those very briefly, and then we can jump into the good part about, hey, what is actually new in iSCSI target, right? Low-cost block storage for Windows and non-Windows. That's basically its claim to fame. And in terms of scenarios, shared storage for failover clusters. This is one of the obvious things that every customer uses it for. When they want to spin up a new failover cluster, they first stand up in a Windows server, make it a iSCSI target, and have multiple nodes access that same storage as a shared storage. Right? And Hyper-V host storage, Hyper-V guest storage. Tier 2 and 3 storage is the other one, meaning if you have like non-test and dev kind of environments that you want to quickly bring up and see network connectivity and your application access to network storage, customers do this all the time. And boot, diskless boot is another big scenario for iSCSI. I have more details coming up on that and what exactly that means and all that. Let's hold on that a little bit. So installing iSCSI target. Well, I told you guys that it's all part of operating system. Well, how do we install it? Well, it's pretty simple. Either you can use command line or you can use Server Manager UI, right? Basically, you select that iSCSI target server checkbox, and that gives you pretty much everything you need on the server side, right? So iSCSI target storage provider, I wanted to call that out, is not the target server. That is really the VDS and VSS providers that get installed on the initiator side, not on the target side, right? And don't do that. It's just target server. That's the only piece you need. Virtualization. I want to talk a little bit about virtualization in the context of iSCSI and clarify a couple of things, because this is another point of typical confusion with the terminology here. First of all, when you see an iSCSI thing, right, an iSCSI box, well, what is it? That is the iSCSI network entity in iSCSI speak, right? Someone says iSCSI storage, I got an iSCSI box, that's what they mean. They have a network entity. Within that, there's 3 layers, right? Think of it as a 3-layered thing. There's really the model I keep using in all the slides going forward. There's the iSCSI implementation, there's the SCSI implementation, there's SCSI personality, and then there's really a place where all this data is stored or read from, whatever, right? So that's the basic concept. And remember that the network entity is not the same as target, right? Network entity is the physical thing, or in typical implementations, and target is the real protocol layer that implements iSCSI personality. So it turns out that iSCSI protocol by design virtualizes targets. You can define as many targets as you like on one network entity, right? So that's this one, right? In Windows implementation speak, when we say iSCSI target server, we mean a network entity, right? There's one service in standalone deployments. That one service acts as the iSCSI target server service, which is acting as the role of iSCSI network entity, right? And you can create as many targets, like I said, off of a single iSCSI target. So now clustering takes it one more level forward, this virtualization concept, one more step forward. What in clustering speak, in a clustered iSCSI target, there are multiple network entities. There can be multiple network entities depending on how many iSCSI target servers you had configured. If you have one clustered role, you have it means you have one target server, right? And you, in a dual active kind of configuration, you may actually have multiple iSCSI target servers all running on maybe one node or multiple nodes. Doesn't really matter. But the meta point is that there's multiple layers of virtualization here, right? There's iSCSI network entity that can have a set of targets, and there can be multiple of those network entities in a clustered implementation. And when I say a iSCSI target is failing over, what I really mean is iSCSI target server with all the targets in it, along with all the sessions connected to those targets, they all fail over as a group, right? So it's a non-trivial undertaking to bring each one of the targets again on the new node and reestablish all the sessions, all the while application I/O traffic is going on, and without missing a beat, right? Without a single I/O failure from the application's perspective. And that's precisely what iSCSI target does in Windows Server. It provides continuous availability to clients running at high workloads. Let's take a very quick tour of iSCSI target server. Let's just start with the top layer, protocol processing. A little bit of detail there on what exactly is the iSCSI personality that we are shipping, 3720 compliant, and it can do CRC offload, and it can scale up to a large number of initiators. In terms of the SCSI personality, SCSI 3 and SCSI 2 reservations are supported, mandatory SBC3, SCSI block commands, and SPC3, the SCSI primary commands, they are supported as well. Data persistence, BHD based, meaning that we map a logical unit to a BHD file of one format or the other. In terms of manageability, we have a full suite of PowerShell commandlets, and you can basically automate the entire end-to-end provisioning workflow, whatever, everything. Pretty much you can do everything through PowerShell for iSCSI. And VDS and VSS integration is all based on the exact same underlying WMI APIs that PowerShell uses. So you can pretty much do everything through WMI. That's your normalized baseline, and on which VDS, VSS, and PowerShell, they all build on top of WMI, right? Snapshots, VSS snapshots, the end-to-end snapshot model works great. There's no problem with that. dual active clusters with continuous availability that I was talking about a little bit ago. And in terms of overall manageability, perf counters, diagnosability with WPP and ETW traces, RAM disk for perf troubleshooting. First of all, if you have a problem with what's going on here, is it my disk or is it my JBOD interconnect, SAS? What you can start with the RAM disk and see if that actually works fine. First of all, to begin with, right? So ISNS-based discovery, very quickly, ISNS is the Internet Storage Name Service, and So it is used by initiators to discover targets, and iSCSI target is fully compatible with INS protocol implementations. Windows Server, of course, itself ships an ISNS service, ISNS protocol itself. And here is a quick way to enable the integration. You basically say, hey, I want to integrate with that particular ISNS server, and it works well, right? When it automatically registers and unregisters every time a new target is created, so the targets become discoverable using ISNS. Diskless boot. I briefly mentioned this earlier. What is diskless boot? Basically, iSCSI target can work with an initiator that does not have a disk and that really wants to boot from iSCSI storage, right? So you can set up the iSCSI target and initiator in a way that the initiator does not need a local disk, but actually boots directly off of the network from iSCSI, Windows iSCSI target. So first of all, on the initiator side, you need a bootloader. It can be a HBA or NIC-based bootloader. It can be a software iSCSI bootloader, right? You have both options. I have two initiators up there in this animation, right? There's diskless client number 1 and 2, red client, green client. And on the target server side, the way we model this is all the initiators that are all using the same primary OS version to boot, you can create a parent VHD that they all boot from, right? Then each initiator, as and when it sort of deploys, i.e. it boots for the first time, we create they map to a diff VHD, right? So here is a red diff VHD and a green diff VHD, right? The green client, the green initiator is accessing booting through the green diff VHD. They have the same golden image, so to speak. They have the same parent VHD, right? So they're working fine together, but they are actually leveraging the same golden image under the covers. So in terms of the diskless boot steps, right? First of all, decide which bootloader you want to use. For example, QLogic HBAs, they have iSCSI bootloader on them, right? So you can use one of those. They are tested with Windows iSCSI targets. They work great. You can use them. Or you can also use software bootloader, iPXE, gPXE, any of the open source bootloaders. They work great as well. We have tested with them. There's blog post. I have a blog post reference at the end of this deck that illustrates how to exactly do this step by step, right? Once you pick a bootloader that you want to use, then create a golden image VHD file using that specific bootloader. That's the thing that you need to create first, and then sysprep it. So what that means is it takes out all the personality details of that specific server, as you know the sysprep process. And on the target, then set up one diff VHD based logical unit for each initiator, right? So use the golden image as the parent VHD. Then as each initiator boots for the first time, it can be, there are a couple of different options here. Again, the blog post goes into a lot more detail on exactly what needs to be done, but they can be, it can be through this hardware bootloader, it can be through software bootloader, or even the software bootloader can be downloaded right runtime using Windows deployment services, right? There are all these options using TFTP. The first boot, the very first time the initiator boots, it's going to take a while. It's going to basically populate the diff VHD with all the customizations relevant to that specific initiator. But once it is done, the deployment boot is done. From the second boot on, you're basically in production. There's just boots like any other boot. First time is the one that's going to take a little bit longer. So that kind of sort of concludes the sort of really quick tour of the high-level features, deployment scenarios of iSCSI Target. And let's jump into what's new in Windows Server 2012 R2. In 2012, we introduced a bunch of cool capabilities, like I said, right? PS command alerts, inbox server feature, continuous availability, all that good stuff. In 2012, what we're doing is we have added primarily two sets of enhancements. One is a bunch of virtual disk enhancements. The other one I would put it in the bucket of manageability enhancements, right? What that means in the virtual disk enhancements is you can actually use VHDX format with iSCSI Target. This is a long pending customer ask. I keep hearing in every customer and MVP presentation. And the good thing is we actually do it now in 2012 R2. And manageability enhancements is we have added new command alerts, and we have included an inbox SMIS provider and to enable the end-to-end SCVMM integration story. And the long-running operations, well, I've got more slides coming up on that actually plays also into the SMIS story. So let's go into more detail on each one of these. Virtual disk enhancements, what exactly am I talking about? I'm talking about the data persistence layer, going back to a reference model, right? Within that data persistence layer, previously we used VHD 1.0, and with 2012 R2, we basically entirely revamped the data persistence layer. We switched to native Hyper-V APIs. There's no longer a separate I/O stack within iSCSI Target Server. This is a good thing that normalizes everything under the same set of APIs, and you get the same benefits everywhere. And if you already have existing VHD 1.0 based logical units, of course they can be ported in 2012 R2. No problem with that. And but new logical units, when you create them, they only get created in VHD 2.0 format. And that's really what we are normalizing on. And by default, when you create a fixed VHDX, it actually zeroes it out as well, just like the Hyper-V APIs do. You can optionally disable it. We don't recommend it for security reasons, but you can go either way. And dynamic VHDX. This has again been a long pending customer ask, meaning it's one way of thin provisioning. You can think of it that way, right? So when you provision an iSCSI virtual disk, you can say it's supported by a dynamic VHDX, and it basically starts from a small size, and then it adds on a block-by-block allocation as necessary, depending on the block size you have defined. So why switch to VHDX? I think I kind of talked to it. This has been a long pending customer ask, but here's a little bit of more color on what VHDX really means to us overall, right? The size, the logical units can be of much larger size, 64 terabytes. And internal logs are available. You can add custom attributes and all that. So this is standard VHDX value proposition. And what we're doing is, hey, why not we normalize on VHDX and iSCSI, right? That's what we're doing in this release. So let's go back to the our demo machine, and hopefully I can access my iSCSI machine better, the client machine at least. Actually, both clients are running on the same machine. But I'll show what I have here, right? So the same two-node cluster, I have an iSCSI target server role running on one particular node. Now, if I go to my server manager, iSCSI, let's try to provision a new iSCSI virtual disk, right? So I am pointing this to basically I have one cluster shared disk assigned to this particular clustered role. So that's G colon, right? So my iSCSI role is going to use that particular shared disk wherever it fails over to between the nodes. I select this, and let's say I'll call it D1, disk 1. And here is the detail that I just want to give a moment's notice to. Right? So this one, this is the new stuff, cool new stuff we added, right? The dynamically expanding, the middle option was not there before, right? Dynamically expanding is the new one. Of course, every one of this is all accessible through PowerShell as well, and we have added a bunch of new parameters to PowerShell as well to make it pretty close to Hyper-V new VHD APIs, right? And the fixed size, within that, you have the option of clearing the virtual disk on allocation, which is, like I said, zeros out by default, and it's there as well, right? Let's pick a size. I don't know, 10 gig. I have a small disk there, so let's go with that. Actually, on the second thought, let's go dynamically expanding, so we don't need to wait for the zeroing out portion. Let me just assign this to one of the pre-existing targets, and that's that, right? So the wizard runs through the creation process and then assigns it to that particular target. The way it works, by the way, is there is a pool, an inventory of logical units in the iSCSI target server backend, right? Within this pool, and the targets are one layer above. You have target 1, target 2, you may have 100 different pool of 100 different logical units in the backend. You can say, hey, I want to use these 41 logical units in the pool to this target, and these other 50 or even 80 logical units to this other target, meaning that the sets can be overlapping in the backend. We don't care, right? All it is a pool of logical units that can be assigned to different targets, and the initiators come talk to the target. So whichever initiator can talk to a target, they see the logical units associated to that target, right? That's really the concept. So what the wizard is doing here is it both not only created the new logical unit and the backing VHDX file for that, but also made the association between this logical unit and the target. So the initiator can actually see this entire virtual disk now. Now, I think my challenge is my initiator is still not accessible, but I'll come back to this for the VMM portion so we can see more. Basically, this is what we have just done, right? So as you click on D1, it shows that this particular logical unit is assigned to this T1 target, right? And it is a size whatever we have allocated, 10 gigabytes in this case, and the path is lit up to the initiator. So when the initiator now runs if you go to Disk Manager or if you go to Server Manager and basically do a refresh or scan of your disk devices, assuming that you have the iSCSI initiator correctly already set up to log into this target, the initiator basically sees the newly provisioned disks on its end, right? My initiator here is unfortunately still not lighting up. That's the same machine that I have used both for CentOS and this one, and that thing is not helping. So anyway, we'll come back to that for the SCVMM portion. I'll show some more integration. But I think that gives you the general idea, right? Once the initiator sees the disk, it can just use it as any other disk. It can initialize the disk, partition the disk, and format it as NTFS, and mount it, give a drive letter, whatever, and start using it, right? So that part all works just like local storage. The only interesting thing under the covers, unbeknownst to the app layer, is that the whole traffic is actually running on iSCSI, right? That's what's going on there. So let's go back to the slides and continue on through the slides, and we'll come back to a different demo. So just to wrap up the virtual disk enhancement side of the story, right? What did we do? More scale, performance, versatility, security, and resilience. And each one of those words I there's a reason behind that. When you read through the deck, you'll see that, right? You can provision very large disks now, 64 terabytes up to 64 terabytes in size. The this resiliency comes from BSDX capabilities. BSDX format is, because of its logging, it is resilient to power failures, and that stuff is all taken care of at the BSDX layer for us. And dynamically growing LUs, the new feature that we added, dynamic BSDX-based virtual disks. Online shrinking and expanding of logical units is now possible with iSCSI Target. Back in 2012, we supported online expanding. Now you can also online shrink if you want to. For example, you deleted a partition or something and you wanted to shrink, that's fine, you can do that. Let's briefly talk about the manageability side of the house. What exactly did we do there? Well, the big thing here is SMIS, right? SCVMM, the System Center Virtual Machine Manager product, that provides as a cool new integration into storage. They have the storage automation feature that the beefed up in 2012 R2. It gets even cooler. It has a bunch of new capabilities to manage Fabric. That includes file servers, fiber channel storage devices, and network devices, and more importantly to this story, iSCSI targets as well, right? So what we're doing is we're including and adding an SMIS provider inbox in 2012 R2, so the end-to-end scenario lights up pretty nicely without you having to do anything special. Back in SCVMM 2012 SP1, you had to go to SCVMM Media or go to website, download an SMIS provider, install it on each one of the targets, and do some work, some legwork. Now you don't need to do any of that. That's all. That stuff is all in there, right? So this is the overall scenario, right? The SCVMM server manages both the storage for the Hyper-V host as well as the Hyper-V host itself. You can provision storage and then assign it to a Hyper-V host, right? So it is inbox and easy to install. Simply install iSCSI Target Server and everything you need, including the WMI provider, including the SMIS provider, everything is automatically installed. The only thing you need to do on the client side is register it on the client so it actually knows that there is an SMIS provider. But I'll show exactly what that means during the demo. It is designed for dual active clusters. Back in the 2012 SP1 version, it was like basically a active passive cluster, meaning that we could not support more than one iSCSI target server in one cluster. Now it doesn't matter however many there are, we'll just handle them fine. Asynchronous job management via jobs profile. This also relates to the zeroing out feature that I talked about in a way, right? Because when you're zeroing out, it could take a very long time for a very large sized virtual disk. And because it's all asynchronous, we want to make sure that there's complete end-to-end story for the async side, meaning the client understands that there is a long-running operation in progress, it can check on its status, it can come back and cancel it if it wants, so on and so forth, right? I have more detail coming up on that. Let's see. Yeah, let's take a look at this one. So this is okay. Let's actually go back to the 2-node cluster, right? So if you see this, right, this is MC demo ITS, my favorite iSCSI target server here. That's the name of this particular iSCSI target server. And within SCVMM, I have SCVMM running here, and the same MC demo ITS provider is basically registered here, right? This is the same guy. Remember I talked about registering the provider on the client side. Client meaning the management client, right? So SCVMM server here is my management client, and I have already done the registration step in advance to save us some time here. But basically, it's pretty trivial to add a new provider by right-clicking on this and say, hey, add new thing, add storage devices. You can add that, right? So that's something I had already done. So you have a SMIS provider that's already responding, working well with an SCBMM server right now. Let's go to arrays. Once it is registered and it gets an inventory of what's there behind that SMIS endpoint, it detects that there is an iSCSI target sitting there with a capacity of 49.87 gigabytes. That's basically the same capacity that we had provisioned to iSCSI target server role in the cluster. Remember, I was talking about the G colon drive, which is the cluster shared disk. That guy's capacity is basically this capacity. So it is the SCBMM server picking that up and saying, hey, I have an iSCSI array that has this much capacity. Now let's look a little bit more deeper into its pools, right? You can go either click on this one, pools, or you can basically go to the classification pools here. So within that, right, this is this has the this has one logical unit already created that I was just testing last night. You can create a new one. We can do that right now. Let's do that. So basically what I got here is that there is a gold classification. Basically you can define your own classifications on which kind of storage it is. And once it's defined, you can put this pool that it discovered. In the pool's name is sort of, I guess I would say, unintuitive. We just call the pool as mcdemo_its_g colon. That's what we reported back to SMIS through SMIS as, right? Simply because a pool in SMIS concept is really the hosting disk, right? Whatever disk that's really hosting all the VHD files, that is what shows up as a pool. And that pool is just being returned back to the SCBMM server as mcdemo_its_g colon. And within that, I currently have one logical unit, but I can create a new logical unit as I like. Within that, I can say, hey, the name is D3. This actually shows up in the description part of let's just call it demo disk, right? This actually shows up in the description part of the disk on the iSCSI target side. So size, I don't know. Let's just pick 8 just to keep it unique, so we know that's the one we just created. And that is basically it, right? I click on that. Oh, sorry. I think I have a space in there. That's not good. Okay. So I click on OK, and that just goes ahead and creates the new demo disk, right? You can actually go to jobs and see what it's doing. Within that, it's just creating it right now. So there's a multi-tier orchestration going on under the covers. SCBMM server is going out and talking to SMIS. SMIS is turning around and talking to WMI provider. WMI provider is going ahead and talking to the iSCSI service. And the iSCSI service is going out and talking to Hyper-V APIs in the back end. So all this orchestration is going on under the covers, unbeknownst to us, and I'm glad we don't need to worry about that, right? So you come back to this, and there is the demo disk created, and this logical unit is now what we have just done is with SCBMM, we just provisioned a disk on iSCSI, an iSCSI accessed logical unit on Windows iSCSI target server, and that entire end-to-end path works fine. And if we refresh it here, right, we should basically see the same here as well. Right? So this is the new one that just got created. Like I said, this is the 8 gigabyte one that we created. And if you look at the properties of it, that's the demo disk that we created from. I don't know if you guys can see this, how well you can see this. Right? So that is basically the 8 gigabyte demo disk that we just created from SCBMM. Right? So once it is created, SCBMM can now provision this to a Hyper-V host, or actually a group of hosts, and it can expose it through zoning, whatnot, right? So that's really the end-to-end manageability scenario with SCBMM plus iSCSI target working in conjunction nicely. All out of the box. You don't need to download, and you don't need to install anything, install the provider everywhere, and make the linkages between the SMS provider and WMI, all this complicated stuff. That's all gone. So it's all in box now. That's the good news, right? Hopefully you like what you had seen there. So in summary, what is it that you could do, right? Let's see. Basically, everything a private cloud administrator would want with their block storage, right? That includes discovering targets, discovering logical lineage properties, target, deleting, creating new ones, masking and unmasking, basically all the operations. I just want to talk briefly about the target migration scenario. 2012 to 2012 R2, right? So we have added some new commandlets here with export and import, and I just want to make you aware of those. You have 2012 server and a 2012 R2 server. What you need to do is, this is a typical question I get when we start a new operating system, right? Hey, I have some existing stuff running on down-level machine. How do I migrate it? Pretty normal operational question. So I just wanted to spend one slide on that. So stop the Quest IO to the old target and copy the virtual disk to the new machine, and export configuration. You run from the 2012 R2 machine, exporting. This is an inbox commandlet. This is a new commandlet, by the way. You can just export it and import it using another commandlet, again a new commandlet that we have added, right? This stuff is, and what that means is, the other thing is, export-import process does not bring over the CHAP authentication passwords if you have any, right? CHAP is the Challenge Handshake Authentication Protocol. That's the one you can use for authentication of initiators and targets. And to the extent you had any CHAP passwords on the old down-level machine, they will not be exported, because once they're written into the registry on the down-level machine, they cannot be retrieved back. Their passwords, we don't want to expose them in the clear. So you need to make a note of it and manually configure them again on the new machine, right? That's the one manual step you do need to remember. Then basically resume IOs to the migrated target and you're done, right? So the export and import commandlets, as I mentioned, they're new in 2012 R2. This is all the standalone migration scenario, by the way. For the cluster migration, there is a cluster copy roles wizard that you probably hear much more about in the payload cluster discussions. But it's pretty trivial, pretty easy to do that. There's a wizard that actually walks you through, and it actually can move the roles from one cluster to a different cluster. Resizing, I briefly mentioned this. 2012 supported online expansion of an iSCSI virtual disk even while it's being accessed by initiators. Now you can also shrink it, assuming that there are no partitions to the end, all the way to the end. The partitions and that are partitions that the initiator sees, right, they still have a lot of room at the end, and if you want to shrink that and pull it back in, you can do that even while the initiator is accessing any of the partitions. And the new resize iSCSI virtual disk commandlet in 2012 R2 does exactly that. Long-running operations, very quickly, the concept is actually pretty basic. I just wanted you to be aware of that, that's all. And the long-running operation is going through all the life cycle of it. You can, when does it get instantiated, by the way? That's what those ABC are. A new SCSI logical unit is created, and because the zeroing out could take a non-trivial amount of time, depending on the size of the virtual disk, it could be a long-running operation. And when the logical unit is expanded, same reason, because it's being expanded, it could take some time. And rolling back to a previous snapshot could also be a long-running operation, because it's really going to the previous wall snapshot and fishing out the specific virtual disk image there and going back to that, right? So if it's doing any of those, automatically a long-running operation is created. And when you click on that, actually, sorry to go back. So when you click on that create button, a long-running operation is automatically created, right? And when you go to the PowerShell, you can actually see that, hey, it's actually going on. It is initializing. You see the status of the virtual disk, the long-running operation status there, right? In terms of cancellation, you can either right-click through UI and cancel, or you can actually use this new commandlet that we have added in 2012 R2, which is the stop iSCSI virtual disk operation, right? You can do either one, either way. Let's see. And you can progress updates. That's all nicely integrated into the UI. You can see them in band as the operation is going on. Other couple of interesting, important changes in 2012 R2. They don't necessarily fit in the manageability bucket or the virtual disk enhancements bucket, but I do want to call them out. One is better optimized to allow disk level caching, meaning we always do unbuffered accesses in the backend on the iSCSI target side. So there's no system level caching, but there can be disk level caching in the backend JBOD or whatever you're using, right? Now, previously in 2012, we always used to do FUA writes. When someone does a write, we do a FUA write. FUA meaning forced unit access, meaning that we're trying to bypass the disk level cache as well. Logically speaking, there's a system level cache and there's disk level cache. We always bypass the system level cache. That's what I mean by unbuffered IOs. And the disk level cache, we always used to bypass this in 2012. That's being super conservative. There's no really good reason for that. And we basically, after a lot of analysis, we said there's really no good reason to do that. That's just affecting performance in a negative way because we're bypassing the disk cache every time unnecessarily. So what we do now is when an initiator fires off an IO with FUA bit set, i.e., if the initiator instructs the target to bypass forced unit access, we bypass disk cache. If the initiator doesn't tell us, we don't bypass disk cache. That actually results in a better performance. Again, that should be a no-op from an applications perspective, but if you have any questions, feel free to ping me offline. Increase of scalability limits. Maximum number of sessions and maximum number of logical units are now both bumped up in 2012 R2. And the local mount functionality for snapshots is basically, we're deprecating that. It still works in 2012 R2. No reason for any panic. If you are using that, very few customers use that. That's one of the reasons we did not want it to be there. And the other big reason is you can actually get the exact same functionality by using a local loopback initiator on the target. So the initiator locally mounts it, and it can access it. So there should be no problem for that. Again, that's a little bit of detail in case you are using the local mount functionality. If you have any questions or concerns, or if you don't want it to go away ever, please do talk to me offline. So wrap up, right? Unfortunately, I do not have the 2012 R2 performance numbers yet. They're still in the lab, and as I was checking, they are still measuring this, so I can't share them with you yet. But I do have pretty impressive numbers from the 2012 round of testing. As you can see here, the iSCSI sessions that we have tested continuous availability with was like 512 sessions. Again, this, like as I was saying, right, as all these 512 sessions from 256 initiators, they're all doing IOs all at the same time. We then fail over the entire thing en masse, including the targets and the sessions and everything in there, right? And without dropping a single IO. And that's what we tested, and that works great. And while we're doing that, the IO workload that's running is this IOmeter workload here. That runs while the planned and unplanned. By the way, we test both with planned failovers and unplanned. Unplanned meaning just go crash the machine manually, intentionally, right? So we do all that. It works well. And IO failures, the important point here is IO failures and VM failures are zero, right? That's what we really mean by continuous availability. Interoperability story. Again, that kind of brings us back to the claim or the purpose of this session. What do we work with? What is the non-Windows story here, right? Interoperability tests is done by a third-party consortium. For those of you who know, University of New Hampshire does a lot of iSCSI compliance testing. And implementation notes, some of these are protocol shortcomings. There may be genuinely shortcomings in the Microsoft Windows Server implementation. Some of them are not necessarily shortcomings, but that actually works well with Microsoft ecosystem. And initiators tested. We tested a bunch of non-Windows initiators. They're all there. And here is another interesting snippet. It's number 3 in the top 10 cool features. Just to summarize, right, it's a scalable, high-performance heterogeneous solution. We ship it in box. It actually provides continuous availability at scale, meaning really when a bunch of initiators using a bunch of sessions are all accessing it and running high workloads on that. And in 2012 R2, we have made a significant set of enhancements, VHDX support, SMS provider, and a bunch of other enhancements, all in box. And I would really love to hear your guys' feedback. How many of you actually use iSCSI Target, by the way? Anyone? Okay, a handful, yeah. Please do use the new feature, and let us know how it goes. And if you run into any bugs, any issues, configuration challenges, do let me know. I would love to hear feedback from you guys. I think that's it. And here are a bunch of related links, that including the diskless boot thing that I previously mentioned. There's a URL to that. Let's see, I think if I can get my click here working. Related contents, and there are some breakout sessions and hands-on labs, and I will be at the storage and networking booth down there. If you need to grab me and talk to me, please do so. And tech resources, and that's that. That's the standard stuff. And please do complete an evaluation and what you think about this session. Again, I would love to hear your feedback on what needs to be improved, either in the feature or in the presentation. I guess that's it. Thank you very much.